Hey everyone, this is Shubhadeep, and in this video I will try to explain you this problem Azamon web services, and this is a part of the TLA Eliminator course, TLA Eliminator 8 level 3, which I am been a part of, and I will try to explain you this problem. I won't be reading the whole problem and the whole problem statement. I will try to like straight up try to explain you the problem and show you the code. I won't be able to live code it because due to some issues with the command line update which I got last night, due to which the GCC is like acting weird on my system. Anyways, I will try to solve this problem and try to explain you the code which I have written over here. And let me tell you that this is an accepted code. I have tried three times before this got accepted. So yeah. Anyways, let's talk about the problem directly. The crux of the problem says that there are two different strings given, string s and string c, and I can use find a like I can perform a swap at most one time, like at most one pair I can swap, or like at most means at most once, or like it can be okay, like it can be okay if I like reach the destination without any swap, and the destination is that I need to make S lexicographically smaller than C. So basically, if you are unaware of the word lexicographically means, it basically is that whenever we are accessing some words in a dictionary. So some the word S should come before the word C in a dictionary. So in dictionary way sorting, I hope you got the gist of the things what I want to say. Anyways, this problem is like I need to make string S smaller than lexicographically smaller than string C using at most one swap. This is the problem, right? It's a greedy problem, and let's talk about the input statement. What we are given T, which is 1500, C and S is up till 5000 it can be. So okay, so let's talk about the solution which I have given. So I've taken input of S and C as a string, and I've taken S answer smaller answer to be nothing. And in NS I've been storing the size of S and size of C, basically the length which I've taken input over here. And this SZ work basically like this. Let me show you. Yeah, here it's basically return the integer value of the size. It can be like you can take dot length. You can use the dot length function, it will act similar, and also like dot size function for vectors. Yeah, it can be, you can use any of the both, it will work fine. And then I've taken what I'm doing is let's say what actually I'm trying to do is in the let's talk in this example. We are given Amazon and Apple. Let's copy this, and let me just explain you the what I'm trying to do. Okay. Yeah, so what I'm trying to do is okay, so let's say here I've been given AZAMON. So I will go at each index. Let's forget about Apple. I will forget about Apple for now, and I will try to find how I can make this this statement lexicographically smaller than itself. Right? How smaller I can make, how much smaller, lexicographically smaller I can make this statement. For that, what I will do is I will go at each index. Like for example, I have an index I over here, and I will traverse the whole the rest of the let's say string, and I will try to find, can I swap this particular index with any of the particular index with any of the particular character. Can I swap it and make it lexicographically smaller than itself what it is right now. So if it is possible, if I'm able to make this string lexicographically smaller than the currently what I'm having, that would be in that case I can ultimately it will be it should be smaller than the string C, because what I am doing at string S is I am making it as small as possible by traversing through the string and try to make it lexicographically smaller, right? I will try to make it lexicographically smaller. Okay, so what I'm doing is, as I said, that I will take one index at a, let's say a, and I will try to find I will try to find the smallest possible the smallest possible lexicographically like smallest possible character which will help me to make this whole string lexicographically smaller than itself, right? So here I have taken like I, and I've taken character m, and this will store the smallest character. Okay, I have taken position -1. This is the position, and by using this I will be able to swap the characters, right? Then I will try to search from j is equal to I to like the last of the character, right? And I will try to find the smallest character that is possible. Now if it is not, if it is like if I have a, right here I have a, so it is not possible for me to find a character which is which will help to, like, with which I can swap it and make this particular string lexicographically smaller. But in the second I have z, when my I will when my I will be here, and I will try to iterate over the rest of the string with j, I won't be able to find something which can swap with a, and that would make lexicographically smaller. It won't be possible. But in the second, like in the first position when I got z, and then at z if I have I, let's consider I have I over here at z. So in that case I will try to find a character with which if I swap this position of z, then this whole thing will be smaller lexicographically. How? Like if I am at z, like let's say I have a, and if I am at z, then I can swap it with az, and rest of the thing will be as it is. And now this is lexicographically smaller than this because az it at the last end, right? And aa will be smaller, lexicographically smaller, or appear in a dictionary before az, amon. Now I'm sorry. So now this is the I can make this least possible, because at further state if I am able to make lexicographically smaller, it won't matter, because at second phase only, like if I'm making az, amon, let's say no, rest of the thing is the same, right? If I am at a, then again a. Okay, let's say here it was b, and I was trying, and I had a over here. So what would be a better answer? Like let's say you decide what could be a better answer. Az, like a b, mo, z is a better answer, or a z mo, b is a better answer. Obviously a b, m, o, z is a better answer, because this is lexicographically more smaller than az, this one, right? So this is the least possible like I can go least in case of lexicographically, if I am talking about lexicographically. So this is the answer which is the best I can get. So I will try to compare it with the string c, and if it is smaller, then the answer is possible, otherwise the answer is not possible. So here, so this is where I am able to search for the lexicographically small, that character, smallest character. So if it is equal to s of I, I'm sorry, once again, if it is smaller than, if it is equal, like the smallest character possible is equal to s of I, in that case I will continue, because it won't be possible. Otherwise I will try to swap and I will break. Okay, let me just a minute, this should be not here. Like if I am able to find, then only I will break, otherwise there's no sense of like breaking it, right? like yeah, this should work, this should work, this should work. Okay, so and then I have a, now if I have made the swap once, then I will try to check whether s is smaller than c. In that case, s answer, shorter answer will have s, and otherwise I will have this and I will print this. Okay, so since I have made some changes on my code, I and I believe this is the correct code, so I will try submitting this, uh, try submitting this. If I am able, I'm like allowed to make only one swap. uh, so yeah, this should work, this should work, this should work. Let's see. And if it doesn't work, then I will try to understand why it is not. Oh, yeah, it worked. So yeah, like only one swap is needed, right? So I have taken it inside the else part. So since you saw that it got accepted, so yeah, that's it for my side. And I will try to like explain more code, more daily problem based code. I will try to explain it, and so that this will also improve my own consistency and will help me to improve my own explaining potential. So yeah, thank you, that's my time. Bye.